Okay, working a little bit more with functions. So now we're asked to state the maximum number of turns for the graph. So think about this. On number 1, that's a cubic. And its parent graph looks like this. Well, how many turns is that? There's 2 turns. Here's a parabola. That's 1 turn. So here's the tip. The highest degree exponent. So for a cubic or a cubed, yeah, a cubic graph, parent graph, there's 2 turns. So 1 less than the highest exponent. For a parabola, it's x squared. There's 1 turn. The number of terms is 1 less than the highest exponent, the highest degree. All right, so let me, get this out of the way. All right, the next thing you have to do is determine the real zeros. That means you have to factor this or use synthetic division to figure out where the graph touches the x-axis. All right, so that's what it means, find the real zeros. And you could use the theorems that we used last week. That would be one way to do that. List the x-intercepts where the graph crosses. So if you had a graph that looks like this. Let's see, let me do that a little bit better. So right here, it crosses where x is equal to -1. That's where it crosses. And where it does not cross, when a vertex sits on the x-axis where x is equal to 4, that is where it does not cross. So that's what we're talking about. That's what you'll need to be doing there. And then just sketch the graph. All right. So we know that state the maximum number of turns. So since it's x cubed, there will be 2 turns at the most. All right. Then you have to find the real zeros. First thing you're going to do is see if you can just simply factor it the easy way. Well, what do all 3 terms have in common? They have an x in common, so you're going to factor that out, and that's going to leave an x squared, an x to the first, and just a 10. Just like that, all right? So then you have to think, are there factors? Those 2 factors would go there, so a 2x and an x. Then are there factors of 10 that we could plug in there where 2x times this plus x times this, the result of all of that will add up to 9x. All right, so let's see if I did. So look, 2x squared is 2x times x. 10 factors to 5 times 2. And then look at 2x times 2. 2x times 2 is 4x. 5 times x. So x times 5 is 5x. Those 2 add up to 9x. All right. So now that we have that, well, this x, remember all of these have to equal 0. So you set each one equal to 0. X is equal to 0. 2x plus 5 is equal to 0. X plus 2. It's the 0 property. If this is equal to 0, 0 times those things is 0. If this zeroes out on the inside, if all of this becomes 0, 0 times each of those things are 0, and so forth. You get the idea. Whoops. All right, so you're just finding what those zeros are. So this one is 0. The opposite of 5, -5. The opposite of multiplying 2 is dividing 2. And here, the opposite of 2 is -2. Ta-da! Okay, so that's what you're doing, and now you have to graph it. So we know that it crosses, the graph crosses at 0. It crosses at -5/2, which is -2.5. And it crosses at -2. So that's, wow, that's going to be a tight fit. So it might look something like this. I'm not going to do this very well. I don't know. It might end up looking something like that. So that you would just kind of give me a rough sketch on how to do those. All right. On this second one, right here, x squared minus 2x plus 1, hopefully you will recognize that that is a perfect square binomial. This is a perfect square. This is a perfect square. And that's a subtract sign. So you take the square root of each of those things. Square root of the first, square root of the second, and you square that. And look, literally, if you look, remember Pascal's triangle? If something's a binomial squared, it's 1, 2, 1. Look at that. 1, 2, 1. It becomes the square root of this, subtract the square root of this, squared. And I believe that's what I did here. And so we're only going to, even though we're supposed to have two roots, we have a repeating multiplicity. We have x is equal to 1, and there's two of those, because remember, x, this squared is this times this. So x is equal to 1, x is equal to 1. That's where you get the multiplicity of 2. And remember what I said last week. When you've got a polynomial and you have x is equal to something with a multiplicity, that means the vertex sits on the x-axis. It does not cross the x-axis. So where x is equal to 1 right here, that's where the parabola vertex is going to sit. All right, that's it for this one.